All right, so a rock is thrown into a still pond. The circular ripples move outward from the point of impact of the rock so that the radius of the circle formed by a ripple increases at the rate of 2 feet per minute. Find the rate at which the area is changing at the instant the radius is 3 feet. So just as an illustration of what's going on, you have a pond here, and then you have a rock that's thrown into the pond. And emanating from where the rock makes its splash is ripples that are going out that form circles as they go outward from the center of impact. So it's telling us that the radius of our circle in the context of the problem in this instant is 3 feet. So R here equals 3 feet. And it also tells us that it's going outward. So these arrows, this ripple here is moving outward at a rate of 2 feet per minute. So that 2 feet per minute is actually dr dt. That's the rate of change of the radius. And we are instructed to find the rate at which the area is changing. So we're looking for dA dt. So the formula for area of a circle, if you recall, is area equals pi r squared. So dA dt is going to equal, if we bring the 2 down in front, we'll have pi times 2r dr dt. And then we just substitute our known values into our expression for the rate of change of the area. So that's going to equal pi times 2 times 3 times 2 for dr dt. So now we just plug all of this information in. We have pi times 2 times 3 times 2, and that equals 37.699. So dA dt, the rate at which the area is changing, is going to equal 37.699 here. All right, so for number 9, we have another right triangle type of scenario. It says a pulley is on the edge of a dock and is 8 feet above the water level up here. So this vertical distance is 8 feet. You have a rope that is attached to the dock that's being used to pull this boat here in towards the dock. It says the rope here is being pulled in at a rate of 3 feet per second. So the rope is going that way at 3 feet per second. And it says find the rate at which the boat is going towards the dock. So the boat is going this way along the water. And it says find the rate at which the boat is going in this direction when the boat is 3 feet from the dock. So this distance here is going to be 3 feet. So if we draw a picture to model our scenario, we have a right triangle. We know our vertical distance is our fixed value, so our vertical distance is going to be a constant in this one. So we can say that this vertical distance, let's just assign the variable. Let's say that's b, and we want it when this distance is 3 feet. So we can say that this is s for distance. S equals 3. And it also says the rope here, this rope is going inward at a rate of 3 feet per second. So this is h, this hypotenuse here is h, and we know that h is changing at a rate of 3 feet per second. So now we need to know what h is for the instant in our problem, so we can use the Pythagorean theorem. We'll do h squared equals 8 squared plus 3 squared. 8 squared plus 3 squared, so that equals 64 plus 9. So h equals the square root of 73. And the square root of 73 is approximately 8.544. So H is approximately 8.544. So now we're going to set up an equation to model our scenario. We know we have S squared plus B squared equals H squared, where S and H are variables. However, B is a constant. So when we take the derivative with respect to time, we know that our constant is going to go to 0. So our derivative here is going to be 2S ds dt, and this will be 0. So this equals 2H dH dt. And we're looking for this rate of change along this horizontal distance, which is going to be ds dt. So we substitute our known variables. We know 3 is s, so 2 times 3. We're looking for ds dt. And that equals 2. Our h is what we found for our hypotenuse here. That's going to be 8.544. times dH dt, which was given to us, which is the speed that the rope is being pulled in. That's 3. So now we simply evaluate this expression here. We are going to finish solving for ds dt. So we're going to have 6 ds dt equals 2 times 8.544 times 3, and that gives us 51.264, and then we're going to divide both sides by 6, and we get ds dt equals 8.544. All right, so for this last question, it says a manufacturer of handcrafted wine racks has determined that the cost to produce X units per month is given by this equation. How fast is the cost per month changing when production is changing at the rate of 16 units per month and the production level is 90 units? So they're telling us that our production unit, which is X, our production level, which is X, is going to be 90 units, and it's telling us that our rate of change, which is going to be dx dt, is going to be 16. So we need to find the derivative of the cost function to figure out the rate that is changing. So we're going to find the derivative of our function. So dc with respect to time is going to equal 0.8x dx dt, and because 7,000 is a constant, we're done here. So now we plug in our values. 0.8, x is 90, dx dt is 16, so we do 0.8 times 90 times 16, and that gives us a production rate of 1152. And because we have a positive value, the cost is indeed increasing here by $1,152 for the expression that we have.